Welcome guys to a new video. Question 5 from a paper 1, AA standard level. It's about derivatives. Let's have a look. Consider the functions f of x minus bracket x minus h squared plus 2k and the function g of x with e to the power x minus 2 plus k. Both h and k are real numbers. Find the derivative of f of x. Okay, let's do it over here. F of x is minus bracket x minus h to the power 2 plus 2k. All of this thing we're gonna differentiate. All right, so when you have things like that, you have to remember, what are you differentiating with respect to? You are differentiating with respect to x, so this is your variable of interest. Anything else than that, such as h and k, are constants, and you know that derivative of constants will be 0. So let's apply this thing. You have power 2, but you also have x minus h, so you'll be using the chain rule. Now let's differentiate the first one. Minus bracket squared derivative. We're going to do minus, take the power down, 2 times bracket x minus h to the power 2 minus 1, which is 1, times the derivative of x minus h derivative, and then plus the derivative of 2k. The derivative of 2k, as I just said, it's a constant derivative, which is 0. Continue solving. Minus 2 bracket x minus h times x minus h derivative. The derivative of x is 1. The derivative of h is 0. 1 minus 0 is 1, so times 1, which brings us to the final answer of minus 2 bracket x minus h. Hope this makes sense. This was part A. Let's go to part B. It says the following: the graphs of f and g have a common tangent at x equals to 3. Show that h equals to e plus 6 over 2. Okay. Now, if we have a common tangent at x equals to 3, this is implying that the derivative of these functions at x equals to 3 must be equal. So in other words, f derivative of 3 must equal g derivative of 3. So we can find each in part. F derivative 3. F derivative x was right here. F derivative 3 is going to be substitution of 3 for x. So we have minus 2 bracket 3 minus h equals to g derivative 3. Now that's some work to do. We go back to the function g of x, which is e to the power x minus 2, and we work it out. We do the following. E to the power x minus 2 derivative equals e to the power x minus 2, and we have the chain rule because we have x minus 2 over there, so I'm gonna do x minus 2 derivative. E to the power x minus 2 times x derivative is 1, 2 derivative is 0, so we get to multiply just with 1, which means the answer is e to the power x minus 2. Now when we want to find out g derivative 3, we substitute 3 into this x, which is e to the power 3 minus 2, which is equal to e. So now I'm going to put e as an answer over there. The question was to show that h is e plus 6 over 2. Well, we have to make h the subject. Let's do that. We have minus 2 on the left side. To get rid of it, let's divide this equation by minus 2 on each side. So we have 3 minus h equals to e over minus 2. And then I want to have h as my subject. I will get rid of the 3 first of all. So I will subtract 3 from each side, and I will have minus h equals to minus e over 2 minus 3. And it's still not good enough because the question says to write and solve for h. So I have minus h. But minus h, I hope you know that this is just minus 1h. So I can multiply by minus 1. Okay, let me draw a line to separate. I can multiply this equation by minus 1, and I will have h as the subject. Minus e over 2 becomes e over 2, and then minus 3 times minus 1 becomes plus 3. And then I can have the common denominator of 2, so I'm multiplying this one by 2, and I'll just have e plus 3 times 2, which is 6 over 2. Is this the answer they were looking for? It says e plus 6 over 2, so yes, we did it right. Good for us. Question C. Show that k equals to e plus e squared over 4. So now we have to solve and show for k. knowing that we have a common tangent at x equals to 3. We have a common tangent at x equals to 3, and we discussed the derivative at 3 must be equal. But what also must be equal is the coordinates of a point for both these functions. To be specific, f of 3 and g of 3 is gonna give us a point that belongs for both these functions. Instead of x, I'll be putting 3. 3 instead of x minus h to the power 2 plus 2k equals g of 3, and g of 3 will be e to the power 3 minus 2 plus k. Okay, then instead of h, I'll be having the following thingy, which I solved somewhere here. I have to substitute e plus 6 over 2. Okay, so minus 3 minus, instead of h, I put the brackets, e plus 6 over 2, close the brackets, and then I have power 2 for the entire bracket, which is going to be right here, plus 2k equals to e plus k. And then I can open the bracket, and I will do the following, minus, here I have 3, here I have denominator of 2. I want to have a common denominator, so I'll just amplify 3 by 2. And I will have 6 minus, if I open the bracket from e plus 6, I should be having e minus 6, because the minus affects the sign in the bracket. And then divided by the common denominator of 2, all of this to the power of 2 plus 2k equals to e plus k. We are getting somewhere. Then I start doing some simplifications. So 6 minus 6, they cancel. And then I have minus e over 2 to the power 2 minus e squared, that's just e squared. 2 squared is 4. This minus was still here, so I'm putting it minus e squared over 4 plus 2k equals to e plus k. I have to make k the subject, so to do that I would like to group 2k and this one over there. 2k minus k will be k, and then I would like to group this one to the right side, so I'll be having e plus e squared over 4. This concludes the question. I'm checking if I did it right. Over here they said that I should prove that k equals to e plus e squared over 4. Yes, that's what we did. We are done. Hope this all made sense. If you like the video, please drop it a like. If you want to watch and follow such content for IB, please make sure to subscribe, and I'll see you in the next one. Bye.